Hello guys, today we will see the problem 1161 maximum level sum of a binary tree. It's today's daily question from Leetcode. So let's see the question. What the question says is the given the root of the binary tree, the level of its root is 1 and the level of its children is 2. Okay, so and so on. So this will be the level 1. This 7 and 0 consist on the level 2. This minus 8 and 7 are on level 3, and so on. That level will be increasing as we go deeper into it. Then return the smallest level x such that the sum of the values of nodes at level x is maximal. So what we have to do here, that the smallest level x such that the sum of the values of the nodes at level x is maximal. So we have to figure out which level having the maximum sum of their nodes, means like the sum of their nodes means node values which are present, this 7 plus 0, 7 plus minus 8 and 1 only. So this will be the sum. Here the sum will be 1, here the sum will be 7, here the sum will be minus 1. So we have to find out the which smallest level having the maximum value. Okay, so first we have to figure out the maximum value, maximum sum, which level having the maximum sum, and after that if any two levels having the maximum sum, so we will have to return the minimum level between them. So let's see the overall idea what the question says. Okay, so this is the 1161 problem. I will explain you with the one of the example. I will take one example, this 2 0 and 4 6. Okay, in this example this will be the level 1, level 2, level 3. Okay, so this 2 contains at level 2, level 1 contains this only 1, and level 3 contains 4 and 6. Okay, so now we will have to find out the sum at level 1 is equal to 1, sum at level 2 will be 2 because 2 plus 0. Okay, level 3, sum at level 3 will be the 4 plus 6 is the 10. Okay, so 10. Now our answer will be this 10. Okay, means our maximum sum will be the 10, and our answer which we will return means the level 3 which is having the maximum sum, so we will have to return the 3. Okay, now if at one of the condition, let's take another condition, that if this child is also as a 6 and 4, and here we will take as a 8. Okay, now this sum, the sum of at this level will be 1, and sum at this level will be 10, this will be 10. Okay, now level 2, level 3, level 1, so level 2 and level 3 having the same sum, so what we will return as an answer will be the level 2, because the minimum level which is having the maximum sum. Okay, so level 3 and level 2 having the same sum but level 2 is the minimum level, so level 2 we will return the level 2. Okay, now how we will approach this? Okay, how we will traverse this, and how this approach we got. Okay, how we will solve this one? So to solve this we have two different approaches. One can be the DFS and one is the BFS. Okay, depth first search and breadth first search. Okay, for DFS we will using the recursive approach, and for BFS we will use the queue. Okay, for DFS you can traverse by using this. I will give us your code. you have to only run a recursive loop of DFS where we have int current and int level, sorry, int level. Okay, so and this, after this we have the current, we have the DFS of its current left, because here the tree node is given, so it will give us the left pointer and the right pointer. Here it is mentioned that the left and the right pointer we will be given, and the value of the node is the root dash value. Okay, so for this we will traverse like this. Okay, then when we pass in the deeper into the node, okay, when we apply the recursion, so we will get deeper into the node, then we will call to the level plus 1, because we will increasing the level. So when firstly we are present at the 1, so our level will be 1, and here for this 2 our level will be 2, and for this 8 also our level will be 2. Okay, so in this way we will traverse the DFS for our current left and DFS for current right, if the left and right child are present only, then level plus 1. Okay, so in this way we will traverse our DFS. Okay, the another approach which is a BFS, okay, I will explain you with this code only. Okay, okay, so when we are traversing this, so the map function will doing the same work in the DFS and also in the BFS. So I will explain you the what the map is doing here. So map is only adding the sum, the node sum into it. So the map is adding the taking the count of the sum of the nodes. Okay, now let's see the BFS approach. Okay, so this is the BFS approach. Okay, first we have the root, then answer, let answer be the 1 or any 0 also. Okay, now here map we have used. This map will contain the the level, and map is a key value pair, so each level the sum of all the nodes at each level, so it will count that the sum of the nodes at that level. Okay, so it will take the count of this. Okay, then we have applied the queue here. Why? To store the root and the level, the level at which that node is present. Okay, we can say it as a not as a root, but as a if we do not call it as a root, so we can call it as a node and level. Okay, node and level, we can call it as a node and level. Okay, so yes. Okay, then we will push into the we will push back into the queue the root node. Okay, root node we will push it into the queue, and after that we will apply a while loop until which the queue is not empty, so the while loop will run. Then we will find out the front of the tree of the queue. Then after that we will figure out the level at which it is present, and then we will pop out that from that queue. Okay, then the map will storing that at that level what is the count means the sum. In simple way we can say that the map is storing the sum of nodes at that particular level. Okay, so it is adding it plus equal to means it is plus equal to doing means it is adding that sum of the nodes. Then if their left and their right is present, so that will be also be adding that will be also be appending to the queue by using the level plus 1. So when the root is having the level 1, so its childs obviously will having the level plus 1. Means if the root is having level 1, so its child will having the level 2. Okay, so both the child will be passing the level plus 1 into their childs. After completing this while loop, the queue becomes empty and the loop will become terminated. Then we will have to traverse our map. So where we have stored all the sum of nodes. Okay, those sum of nodes. Now we have to figure out that which level is having the maximum sum. Okay, so if any of the level is having the sum which is greater, okay, so we will make it as a answer is equal to I dot first. Okay, I dot first. So map of answer will storing the sum of that particular level. And if that current I is storing the greater sum than the map of the answer, that level, so it will be changing the answer to I dot first, and after that we will return the answer, means the level which contains the maximum sum, the minimum level which contains the maximum sum. Okay, and if we haven't written here the greater than or less than or equal to, if we have written here the less than or equal to, so it will be treated as a maximum level with the maximum sum. Okay, because we are going in the in the ascending order, because map is already storing them in the ascending order. So the level 1 having the 10, okay, I will explain you this what the concept is behind this, because the map is storing in the ascending order only. So the map of the value of 1 means the level 1 containing the sum 20, just as an example, and the level 2 is also containing the sum 20. So the maximum sum is also 20, so max sum is also 20. So when we have here less than, okay, less than not, I dot second, when I dot second is greater than that, okay, so this will be changed, that answer will be changed to 1. Okay, now if this 20, now this 20 is not greater than, so this answer doesn't change. Okay, so we will get the 1 as answer. But if we have here as a less than or equal to, so our answer changes to this. Okay, so in this way this map works. If you have used here the unordered map, so it will doesn't work like that, because unordered map doesn't store it in the ascending order. Okay, so I will write here that map stored in the ascending order, and unordered map map in it doesn't store, it doesn't okay, it doesn't store, and it is stored in the ascending order. So this is the that you have to keep in mind, okay, when you are storing it in a map or unordered map. But the time complexity is nearly same, not the vast difference between them. Okay, so this is the solution of today's question. So if you doesn't understand any of the concept, so you can comment it below, and I will try my best to answer those comments. Thank you.